Welcome back to another lesson in our Common Core Algebra 2 series. Last night we talked about logarithms, and today we're going to focus on laws of logarithms. So we want you to go ahead and copy this table down. We basically are going to have a law, an exponent version, and a logarithm version. So the first law is called the product law. Now we've already talked about that in exponents. In exponents, we're saying x to the a times x to the b. Remember, when we multiply, we keep the base, so the base remains x, and we add the exponents, a plus b. Now we're going to apply the logarithm version. Well, since a logarithm really is an exponent, you basically follow what the exponent does. Notice it adds. So here's our first law. The log of a times b is equivalent to the log of a plus the log of b. So let me say that again. Because a logarithm is an exponent, I'm adding, just like I did when I multiplied, I added exponents. So I'm saying the log of a times b is equivalent to the log of a plus the log of b. The second law is the quotient law. So again, in exponents, we said x to the a divided by x to the b. We keep the base of x, and we take those exponents and subtract. So now in logarithms, since again a logarithm is an exponent, we are going to subtract logs as well. So I'm going to say the log of a divided by b is equal to the log of a minus the log of b. And again, they're easy to remember, the properties, because it really just comes from the exponent. Now, the third one's the power rule. Again, in exponents, we said x to the a raised to the b is just multiply, so that's x to the a times b. In logs, we're going to say the log of x to the n power is equal to, now this one's a tad different. What we do is we take this exponent and we bring it down in front. So this is equal to n times the log of x. So there you have it. We have 3 log laws that we have to have memorized. Now we're going to apply them in certain different scenarios. So our first set of directions says use log properties to evaluate. So what I've done, and I've posted this on every page, you don't need to copy it down for yourself, you already have it in your notes. I've listed the 3 log laws. The product law turns to addition, the quotient law turns to subtraction, and then this power law, which brings that power down in front. So we're going to evaluate this log several different ways. Now, like we talked about yesterday, we said when we see the word log, we're just saying what power in our head. What power of 2 is 32? So I'm saying what power of 2 equals 32? And we should know that answer off the top of our head because 2 to the, hopefully you've said it, 5th is 32. Now, we're going to evaluate this just in different ways. Again, we know the answer is 5, but we're going to apply all 3 log properties. So let's start, and we'll call this the product rule, or product law. What we're going to do is we're going to replace 32 with a product of any 2 numbers. So I'm going to say log little base 2, and I'm going to pick 2 numbers to replace 32 with. I'm going to say 32 is really 16 times 2. Okay, now that you have a product inside here, you can go up and apply this property. So I'm going to say this is equivalent to log base 2 of 16 plus log base 2 of 2. And again, I just applied this property. When I see a product, I can split it into addition. Now, hopefully, you know each of these answers. Remember, log is what power? What power of 2 is 16? And I know that answer is 4, plus what power of 2 is 2? And that's a 1. And 4 plus 1 is 5. And you'll notice you should get the same answer because we're just evaluating them in different ways. Now, would this have worked with any number? Well, as long as it's a power, it's definitely going to work. So now let's apply the quotient property. Okay, so again, I just want to go back and I want to replace 32 with a quotient. So let's pick two numbers. What two numbers divide to 32? I'm going to replace 32 with, 64 divided by 2. So I'm making a quotient, and now I'm going to apply that property. And that property says, take the log of the top minus the log of the bottom. So this is equal to log base 2 of 64 minus log base 2 of 2. Now again, I'm hoping I know these answers. And I'm just saying, remember, log is what power? What power of 2 is 64? And that's a 6. Minus what power of 2 is equal to 2? And that's a 1. And again, I get an answer of 5. So again, I should be getting the same answer every single time. All right, let's try the last one, which is the power property. Okay, my power law. So again, I want to replace 32 with a power, something to some power. Okay, so I know 32 is equivalent to 2 to the 5th power. Now that property says you're going to take that exponent and just bring it down in front. So I'm going to say this is equal to 5 log base 2 of 2. And again, I'm going to put it times there. It's 5 times log base 2 of 2. Now I can evaluate log base 2 of 2. So I'm going to say this is 5 times. This again is what power of 2 is equivalent to 2. And that, of course, turns into a 1. And 5 times 1 is 5. So you see, I evaluated the same function with 3 different log law properties. All right, so 2 says log base 6 of 4 plus log base 6 of 9. What is that equivalent to? All right, so if I knew the answer, I would just go ahead and get it. But I'm saying what power of 6 equals 4 and what power of 6 equals 9? Well, is that a number you can come up with on the top of your head? Well, I know it's not 1 because 6 to the first is 1, so I know that number has to be smaller than 1. And I know this number is actually between 1 and 2. If 6 to the first is 6 and 6 squared is 36, then the answer of 9 has to fall between 1 and 2. So since I can't actually evaluate that, I can say, wait a minute, this looks like one of the log properties. So take a look at your log properties here, and which one says log of something plus log of something? Well, that's that first property. So I'm basically going backwards. I'm giving you this side, and you have to come up with this side. So all it says is take log, keep your base of 6, and if I saw addition, that means it came from multiplication. So that's really the log base 6 of 4 times 9, which is equivalent to log base 6 of 36. Now, is that a question you can evaluate? Well, of course, because I'm just saying what power of 6 equals 36. And hopefully we know that answer is 2. All right, so log base 3 of 27. Now again, I bet you know this answer off the top of your head. What power of 3 is 27? I think I heard you. You said 3, and that's a great answer. Now again, I just want to apply the log properties. Let's just start with the product property. I'm going to replace 27 with two numbers. What times what? Well, I'm going to go with 9 times 3. And now that I have the times in there, just apply the property. So that's equivalent to log base 3 of 9 plus log base 3 of 3. And we already know the answer is 3. Let's prove it. What power of 3 is 9? Well, that's a 2. And what power of 3 is 3? Well, 3 to the first, which gets me a total 2 plus 1 of 3. All right, so don't cheat yourself. You try using, whoops, let me put that quotient property in there. You try the quotient property. Rewrite 27 as a quotient of any two numbers. So let me try one. What if I just doubled it? 54 divided by 2. Would you agree that's 27? Well, here's the problem with that one. If I expand that out, log base 3 of 54 minus log base 3 of 2, following this property, can I actually do that? Do I know 3 to what power is 2, or 3 to what power is 54? Unfortunately, no. So I just have to pick maybe smarter numbers. I have to pick ones that I can do 3 to a power of. So I'm going to kill that and try log base 3 of, what about 81 divided by 3? Now I can say that's log base 3 of 81 minus log base 3 of 3. Now I think we know that because I'm just saying 3 to the 4th is 81 and 3 to the 1st is 3, so I get my answer of 3. So again, you do have to be creative and make sure you pick, functions that you can take the log of. Lastly, to get the power property, I'm going to say log base 3, 27 is actually 3 to the 3rd. So remember, replace it first. Now this property just takes the exponent and brings it in front. So I'm going to say that's 3 times log base 3 of 3. So that's 3 times 3. What power of 3 is 3? Well, that's a 1, so I get a 3 again. All right, simply just express in terms of x. That means you should get an x in your answer, that's all. So just ask yourself, which property are you staring at? Well, if I read it, it says 9 times x, so I know that's the product property. And again, when you multiply exponents, you add, so you're just going to turn this into addition. I'm just going to say this is log base 3 of 9 plus log base 3 of x. Now you can actually evaluate one of those. I know what power of 3 is 9. Well, of course, that's just a 2. But this one, notice it said in terms of x, so you better just leave x in your answer. Let's box that in as our final answer. We can't go any further. Number 5, log base 3 of 81 divided by 3. So I'm going to go right off the bat and say I see a quotient. And think in exponents, when you divide, you subtract. So I know this turns into subtraction. Log base 3 of 81 minus log base 3 of 3. And I can evaluate this because I'm just saying 3 to the what power is 81. And 3 to the what power is 3. So 3 to the 4th is 81 minus 3 to the 1st. So just a nice answer of 3. All right, number 6, log base 3 of 72 minus log base 3 of 8. Now notice, this piece you know off the top of your head. Log base 3 of 8 just is what power of 3 is 8? You know that answer is a 2. But I don't know 3 to what power gets me 72. So I would be stuck there, and if that's not a multiple choice, which it probably won't be, I'd have to get more creative. So you'll notice I'm saying, when I subtract in exponents, that means I must have divided, remember. Subtraction came from division. So I'm just going to go ahead and use this property. And they gave me this side. I just need to convert it to this side. So I'm saying log base 3 of 72 divided by 8, which is equivalent to log base 3 of 9. And of course, what power of 3 is 9? Just a nice 2. All right, again, I see division, so I'm going to use that property that says when I divide, it just turns into subtraction. So I'm going to say this is equivalent to log base 2 of 16 minus log base 2 of 32. Again, I'm just saying what power of 2 is 16? I think that's a 4. And what power of 2 is 32? I believe that's a 5, so I get a negative 1. Now, you could do this property, or solve this problem with the exponent property. Watch this. Would you agree that log base 2 of 16 over 32, that divides into a half? Okay, now watch how I can rewrite this again. 1 divided by 2 is really 2 to the negative first, right? 2 to the negative first is 1 over 2. Now I can use that power property that says just take that exponent and bring it down in front. So negative 1 times log base 2 of 2. And this really just says what power of 2 is 2? Well, that's 1. And I have negative 1 times 1, which is a negative 1. So lots of ways to go about it. Number 8, log base 2 of 8 to the 16th power. So again, you'll notice I have that power rule. So I'm going to go ahead and say the exponent just comes down in front. So I'm going to bring that exponent in front and say this is really 16 times log base 2 of 8. Again, 16 times. What power of 2 is 8? I'm just going to say that's a 3, and 16 times 3 is 48. Again, this example wants us to leave our expression in terms of x. So you're not going to get a definite answer here. We'll just have an answer in terms of x. So I'm just going to use my properties. Now, there's two properties hidden in here. Do you see both of them? Obviously, division is the obvious one. And you'll notice you have a power. So you actually have to use both the second property here and the third property. So I'm just going to slow down and do it in 2 steps. And once you get good at it, you can probably do it all in 1 step. But like I said, I'll slow down and do it in 2. So I first see division. And again, log means exponents. When I divide, I subtract. So I'm going to say this is really the log of x squared minus the log of 1,000. Okay, now, there's another little bear trap in here. We talked about common logs the other day. Notice they didn't give me a base. So you've got to be smart enough to say, okay, when I see a common log, I'm going to slap my own 10 in there for my base. Okay, so at the moment, I applied this property. Now we're going to go ahead and use the second property here, which is the power, because you have this power right here. So you can take that 2, and remember that just comes down in front. So I should get 2 times log base 10 of x minus, now this is one you can evaluate because you should know 10 to the what power is 1,000. And of course that's cubed. So my final answer, let's box that in, should be 2 times log base 10 of x minus 3. Notice it said in terms of x, which just means you should get an answer of x someplace in your final answer there. Okay, so these slightly get more exciting. Number 10. If a equals log of 3 and b equals log of 2, find log of 12. Okay, so my first goal, remember, is just to get rid of the 12 somehow. And you want to use one of these properties. You either want something times something, something divided by something, or something to a power. There's not always one right answer. You can get creative. So I'm going to say I'm going to replace 12. Now here's the only catch, guys. You're only allowed to use the numbers 3 and 2. So 12 could be what? I could say 12 is equivalent to 2 squared, which is 4, times 3. Would you agree with that? You're just replacing 12, and you can only use the numbers 3 and 2. So that's really 4 times 3, which gets me 12. Now I'll apply the properties, and I see 2 properties. And again, I'm going to go nice and slow. The first one I see a multiplication, so I'm definitely going to use this property. So I'm going to say that's equivalent to log of 2 squared plus log of 3. Now you've got one more property in there. You've got that power property because this guy has an exponent. So this is now 2 times log 2 plus log 3. And it says once you have log 2 and log 3 in your answer, you can replace those with a and replace this with b. So I would say this final answer is 2, and we know log of 2 is equal to b, so 2b plus log of 3 is a, 2b plus a. Now let's work that problem out another way. Using only 3 and 2, how else could you replace 12? We did 2 squared times 3, but I think you can replace 12 another way. Couldn't you say 3 times 2 times 2? 3 times 2 is 6 times 2 is 12. So notice, it's still that product property. We're just going to keep going. So I'm going to say it's really the log of 3 plus the log of 2 plus the log of 2. Okay? So again, there's not always one correct way. I can go about it another way. And now, I'm just going to replace them again. When I see log of 3, I can put an a. So this is really a plus b, which you'll notice is a plus 2b. Same exact answer because we solved the same problem, just 2 different ways to do it. Let's try one more. Find the log of 18. Okay, so remember, you want to replace 18, but you can only use the numbers 2 and 3. Come up with something. So pause it and come up with something. So these were my 2 options here. I said I could either do log of 3 squared, which is 9 times 2, or log of 3 times 3 times 2. So I'll do them both out. Using this first one, I'm going to say this is the log of 3 squared plus the log of 2, which is really 2 times the log of 3 plus the log of 2, which is 2 times, log of 3 was a. So 2a plus b. Or, hopefully I get the exact same answer. I could say, going this way, it's the log of 3 plus the log of 3 plus the log of 2, which is really a plus b, which of course is 2a plus b. So you'll see I got the exact same thing, but the whole key was just to replace the number with the givens. Alright, log of 500. So again, here's where you got to be smart and say there's no base, so you know that there is a base of 10. Put your own 10 in there. And now you can apply any one of these you want. You can write it as a product, a quotient, or a power. Right off the top of my head, I think of 100 times 5, so that's what I'm going to use. 5 times 100, so I'm replacing it, and now I'm going to, it's called expanding when you use these properties. I'm going to say that's equal to log base 10 of 5 times log base 10 of 10. So again, one of these I can figure out. Log base 10 of 5, I don't know off the top of my head because I don't know 10 to what power equals 5. But I do know log base 10 of 10 because 10 to what power is 10? And that's a 1, of course. So I would say basically my answer, all I can do is say this is log base 10 of 5, and I'm going to leave it just like that because I can't go any further. Now, way back, before they let you use calculators, they used to give you these tables upon tables of logs, called log tables. So the Common Core has thrown these back at us. So it says use the logarithm tables below to approximate these logs to 4 decimals. Do not use a calculator. Alright, so simple enough. You just have to replace 300, but you have to use these numbers. You either have to use 1 through 5 or 6 through 10. So right off the bat, I'm thinking, well, I can't use 3 times 100, but I can make 100 with 10 squared. So I'm going to say this is equivalent to 3 times 10 squared, which is really 3 times 100. But again, I'm just using one of the given x values. Now I'm going to expand that out with my properties, and again, hopefully you see 2 properties. I'm going to do it all in one step by now. Hopefully you can get that as quick and easy as well. Multiplication turns to addition, so that's log of 3 plus, this is really the log of 10 squared, and the exponent always comes in front. So 2 times the log of 10. So again, you're just going to use your table now. It's pretty straightforward. Log of 3. So I go to x equals 3, log of 3, plug it in. 0.4771 plus 2 times the log of 10. Well, you actually know that because the base is 10, and 10 to the first is 10, and you can verify it from the table, is 1. So I would say that final answer is 2.4771. Okay, so we're just using a log table instead of a calculator. Now, they love giving you these and telling you to do it without a calculator. And it's simple, it's just scientific notation, and you've done that since like 5th or 6th grade. So, remember, you can only use the numbers in the table. So I could take this decimal and move it 1, 2, 3, 4. So I'm going to say that's equivalent to the log of 5 times 10 to the negative 4th. And let me explain again what I did to get that if you're a little rusty on your scientific notation. We like to have one number to the left of the decimal. So I took my decimal and I moved it 1, 2, 3, 4. That's why I'm using a negative 4 here. And I want one number to the left, which gets me a 5. So 5 times 10 to the negative 4th. So again, I see 2 properties. I see multiplication, which means addition, and the power property. So I'm going to say that's a log of 5 plus, bring the exponent down, negative 4 log of 10. Again, just reading from the table, log of 5 is 0.6990. Log of 10 is 1, and 1 times negative 4 is 4, so a minus 4. And I get negative 3.301. Alright, so same idea. I want you to use the log tables and rewrite this. So when you think 80, just pick You can pick any number on here. And remember, 10 is always fair game because you know log of 10. So I'm going to do this last one with you and then give you some on your own here. So I'm going to replace 80 with 8 times 10. And now I'll expand. So I'm going to say that's the log of 8 plus the log of 10. I'm just going to read log of 8 from my table, which says 0.9031. Log of 10, remember, means what power of 10 is 10? That's 10 to the first. So I get 1.9031. Okay, so I'm going to pause it. Don't cheat yourself. Rewrite each of these and use that table to figure it out. Good luck. Turn it back on when you're ready to compare answers. All right, you can quickly see what I did. 7 times 1,000, expanded, grabbed from the table. Again, I moved this so there's one number left of the decimal, 1, 2, 3, 4, 5. That's why I'm using 6 times 10 to the negative 5th. This number got smaller than 1, so I know my exponent's negative. Expanded, you can follow my work. Pause it and go back if you need to. This was already written in scientific notation, so I just expanded it out, brought that exponent down, and there's my final answer. I've got 2 quick problems left. All right, we're going to expand this out. Now, there are a lot of log properties going on here. The first thing you have to do is rewrite this for yourself. How do you rewrite a square root? And that's the whole key. I'm going to say that's x to the 1/2. And I have y to the 5th, and I can rewrite the cubed root as z to the 1/3. Now, I'm going to expand this out using all the properties at one time. Notice you have a product property, a division property, and 3 power properties. So, I'm just going to slowly write it out. I'm going to say this is the log of x to the 1/2, but where are you going to move that 1/2? Hopefully you said in front. Multiplication turns to addition. Hopefully you're saying log of y to the 5th, but remember that 5 is going to come down in front. Then I see division, which turns to subtraction. So I'm going to say that's the log of z to the 1/3, but remember the 1/3 comes down in front. And you have fully expanded. For our last problem, we're going to condense. We're going to take these 3 pieces, follow the properties, and make one log. So log of x isn't really anything fancy. I'm going to pull my log out front. Notice I see a plus sign, which means that these 2 are going to get multiplied together. So I'm going to say that's actually x times, not going to say 3a. If the number's in front, that means it came from the exponent. So that's going to be a cubed. My subtraction means these logs were being divided, so divided by. Again, when this 1/5 is in front, it means it came from the exponent. And instead of saying p to the 1/5, we're going to call that the 5th root of p. So I went from an expansion to one condense. And when you condense, maybe make a note to yourself, you only want to have one log in that final answer. All these logs just come into one. Well, we'll get a lot of practice in class tomorrow. Have a great day.